Hello, this session, let's discuss all about DC circuits. So, meron tayong isang circuit, ito. So, i-solve natin siya using this theorem, the Ohms Law. It states that the voltage across a conductor is directly proportional to the current flowing through it. So, we have this formula, the voltage V is equals to I times R, where V is for voltage, the unit is volts, I is for current, and then the R is for resistance, the unit is ohms. So let's solve this circuit using this Ohm's law. So solve the current flowing through the 6 ohms resistor. So let's solve this using the Ohm's law. Here is our solution to the problem. Okay, so did you notice that this 8 ohms is connected in series with the 30 volts power supply and connected parallel to the combination of 3 ohms and 6 ohms resistor. So, na-observe natin that itong dalawa, they're connected in parallel. So, the total for that, for these two resistors connected in parallel, can we call it R1? That is 3 times 6 over 3 plus 6, and then we get the 2 ohms. So the answer for these parallel resistors, the answer is 2 ohms. And then let's redraw the circuit. Okay, so we have this 30 volts, connected with the 8 ohms, and then make a label 30 volts, and then this is 8 ohms, and then for this R1, the value is 2 ohms. Okay, so for this gamitin natin yung technique na voltage divider, can be called as B2, where for voltage divider B2, that is the total voltage till 30 volts times the resistance itself, that is 2 ohms. Okay, so divide by the total combination of this 2 series resistors, that is 8 plus 2, and then we get the voltage of 6 volts. So therefore, ang voltahe nitong dalawang circuit na to, this 3 and 6, is same as this B2. That is 6 volts. Okay, so if you observe the circuit, if this is positive and negative P2, so the same with this 6 ohms, that is because they're connected in parallel. So to solve for the current, we have for the I3, or the current for the 6 ohms resistor, that is just B2 over the 6 ohms resistor. Thus our value for B2, that is 6. Okay, so 6 divided by 6, that is just 1 amperes. So therefore, the current flowing through the 6 ohms resistor is only 1 ampere. So that's how you're going to solve by using the Ohm's law. So the next let's solve again this problem using KCL and KVL. So for sure yung kanilang answer dapat magtugma sa value na 1 amperes. Okay, so let's continue. The next is the KCL and KVL, or known as Kirchhoff's current law. And then the second one is the Kirchhoff voltage law. So the Kirchhoff's current law, or known as KCL, states that the algebraic sum of currents entering a node or closed boundary is 0. And Kirchhoff voltage law, known as KVL, states that the algebraic sum of the voltage around a closed path or loop is 0. So let's solve this problem circuit using the KCL and KVL. So let's solve this. Let's look for the value of current I3 flowing through this 6 ohms resistor using the technique of KCL and KVL. So here's the solution. Okay, so first is let's use the KCL condition. Okay, assume that this current flowing through the 8 ohms, we call that as I1, and then the current through this I3, that is I2, and then from here, that is the I3. So from the law itself, KCL, that the algebraic sum of the currents entering a node or closed boundary is 0. So from that, we can create a equation, that is I1 is equals to two currents are leaving, that's I2 and I3. So this, that is I2 plus and then I3. So this is our equation number 1. Next is by KVL. States again that the algebraic sum of all voltage around or closed path or loop is 0. So we can assume that this, the voltage for the 8 ohms, we call that as V1. The voltage for the 3 ohms, we call it as V2. And the voltage for 6 ohms, that is V3. So as if we use this KVL on this loop, that is 30 volts minus this V1, okay, and then minus V2 is equals to 0. So that is our equation number 2. And then from this 8 ohms resistor, we all know using Ohm's law that the value for I1 is equals to the voltage V1 over the 8 ohms resistor. And then the value for I2, that is just V2 over 3 ohms resistor. And then the value for I3, that is B3 over 6. And then from that, let's substitute this value or this condition from the from our equation number 1. So from that, From equation number 1, I1, our I1 is B1 over 8. Okay? Is equals to our I2, that is B2 over 3. And then our I3, that is B3 over 6. And then we know that these 2 ohms resistors are connected in parallel, so therefore their voltage are the same. So therefore this B2 is just the same as the value for B3. So from this, let's substitute that to the equation number 1. Okay, so we have B1 over 8 is equals to, we have B2 over 3 plus this B3. Let's use the condition that the same as B2, so we can have B2 over 6. Okay, after that we can just simply add this to 1/3 plus 1/6. Okay, so we have B1 over 8 is equals to B2 over 2. So 1/3 plus 1/6 is equals to 1/2. And then just cross multiply it. We have 2B1 is equals to, we have 8 V2. So we can cancel this 2. So therefore our V1 is just equals to 4 V2. And this is our equation number 3. Okay, and then from equation number 2, that is 30V, or that is 30 minus B1 minus B2 is equals to 0. So from our equation number 3, we can substitute this value of B1 from this equation. So to continue, we have 30 minus the value for B1, that is 4V2, and then we have minus V2 is equals to 0. So to continue, we have 30 minus, so that is negative 5 V2 is equals to 0, or our V2 is just the same as, we have 30 over 5, or 30 divided by 5, that is 6 volts. So therefore the value for V2 is equals to 6 volts, and then from that we can substitute that value to the equations from the Ohm's Law. From this equation, I3 is equals to B3 over 6. So let's use this formula or equation to solve for the value of I3. Thus our I3 is equals to, so our V3 is the same as this V2, and the value for V2 is just 6 volts. Okay, so let's use that. So V3 is equals to 6 over 6, so that gives us 1 ampere. So therefore the value of our current from the 6 ohms resistor is 1 ampere. So the same with the answer from our previous technique, that is Ohm's Law. This is the mesh current analysis. So we have here the steps to determine the value for the mesh currents. So first is assign mesh currents I1, I2, and IN, and to the n meshes. Next is apply KVL to each of the n meshes and use Ohms Law to express the voltage in terms of the mesh currents. And then the resulting in simultaneous equations to get the mesh currents. Okay, so from this circuit, we have two loops. We call this as loop A, or we have IA, and then this loop, we consider this as loop IB. Okay, so here's our solution. So first is apply mesh to the loop E. Okay, so mesh at loop IA, and then again this mesh is the also known as the mesh current analysis. So to do that, the current flowing through the 8 ohms is the IA, so we can have 8 IA, and then plus, and then the current flowing through these 3 ohms resistor is IA, and then minus IB. So we can write the IA minus IB, and then we have the power supply of 30 volts is equals to 0. So therefore, we can have an equation that our IA is, we have 8 plus 3, that's 11, and then plus IB, we have negative 3 is equals to 30, or and then this is our equation number 1. And then after that, we can have mesh again at loop IB from this circuit. Okay, so to do that, the current flowing through the 6 ohms is the I3. So we can write IB, sorry. That's IB times 6 plus the current flowing through the 3 ohms, that is IB minus IA, and then that is equals to 0. And then simplifying this 3 of this one, we can have our IA is negative 3, and then itong ating IB, that is 6 plus 3 is equals to 9 is equals to 0. So this is our equation number 2. And then let's get this equation number 1, that is for IA, and then for this IB. Okay, so our IE, that is 11, and then that is negative 3, and then we have 30. This is for constant. And then for mesh at loop B, we have negative 3, and then we have 9, and then is equals to 0. And then by using calculator, by using ES plus calculator, we can have that our IA is equals to 3 amperes, and then our current IB is equals to 1 ampere. So from that, this IB is the same with the current flowing of I3. Okay, so from analysis that this current IB flowing through this loop, this is the same as the current flowing to the 6 ohms resistors, that is the value of I3. So therefore, we can conclude that the value for I3 is just the same as IB, and that is 1 ampere. Okay, so that's how you're going to solve for the using mesh analysis. Okay, so quick review. Just assign the mesh current. If there are 2 loops, so you have 2 mesh currents, that is IE and IB. And then after that, you can have this matrix 2 by 2. Then by using calculator, we can arrive that our I3 is just 1 ampere. Okay, next is the nodal voltage analysis. This one. So solve the current flowing through the 6 ohms resistor. Okay, so again, so the steps to determine the nodal voltage. First, select a node. Okay, so this is our node. Can we assume that this is let us see by. Assign b1, b2, and to the remaining n-1 nodes. Then apply KCL to each of the n-1 non-reference nodes. Then use Ohm's Law to express the branch circuits in terms of node. And then the resulting equations, we can have the unknown node voltage. Okay, so we have this junction. We can call that as by, and then if we're using nodal, let's connect this circuit to ground. So from that, if you're using nodal, assume that all currents are leaving. So I can assume that this is I1. Okay, from the left side, it's I1. Okay, current downward, that is I2. And then from here, that is current I3. Okay, so the 3 currents are leaving. Here is our solution. So from this junction, we can construct an equation that I1 is I1, okay, plus I2, all currents are leaving, plus I3, and then they are all leaving the node, so it's equals to 0. Okay, so again, we all know that the Ohm's law, the current is equals to voltage over the resistance. So from this junction, it's I1. From by, so our current I1, we can have that is by, B higher minus lower, that is minus 30 over 8 ohms. Okay, then plus the value for I2, that is by over 3, plus the value for I3, that is by over 6, is equals to 0. And then from that, we can combine like terms, like for this by, we have 1 over 8, plus we have 1 over 3, plus we have 1 over 6 is equals to this constant, negative 30 over 8, transpose to the right side. That gives us 30 over 8. And then adding this 1 over 8 plus 1 over 3 plus 1 over 6, that is 5 over 8 is equals to, we have 30 over 8. And then we can cancel out this denominator 8, so we can have our by is equals to, we have 30 over 5, and that gives us 6 volts. Okay, so very short solution. So this is now the value for our by. So this I3, we all know that this is just by over 6. So from that I3 is equals to, we have by over 6, where our by is just equals to 6 volts over 6 ohms. That gives us 1 ampere. Okay, so that is the answer to our circuit. The current flowed through the 6 ohms resistor by using the nodal voltage analysis. Okay, next is the Norton's theorem, in which it states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source IN in parallel with the resistor RN. Okay, and then where IN is the short circuit current flowing through the terminals and RN is the input of equivalent resistance at the terminals when the independent sources are turned off. So this is the Norton's equivalent circuit. We have IN, the Norton's current, RN, the Norton's resistance. Okay, so let's solve this circuit using Norton's theorem. So here is the solution. Okay, first, so let's draw this Norton's equivalent circuit. We have, okay, we have IN. Okay, that's our IN. And then we have this, we call the RN. And then this one, this will be the our load, or this is the resistance of 6 ohms. Okay, let's draw it properly. Okay, this is 6 ohms resistor, and then this current flowing through this, that is the I3. So now hanapin natin tong value ni RN. So paano? Okay, let's short this power supply. That is 30 volts. Okay, later on i-short natin yan. This is 3 ohms. And then this is now the RN. Tinanggal natin tong load na 6, nilagay natin dito sa circuit ni Norton's. Okay, and then make a label. This is 8. This is 3 ohms. And then let's short the power supply. Okay, so we all know that these two resistors now are connected in parallel. So therefore, our RN, that is just 8 times 3 over, we have 8 plus 3. That gives us, we have 24 over 11 ohms. So our RN is equals to, we have 24 over 11 ohms. Okay, so not readable. We have 24 over 11 ohms. Okay, after that, so let's look for the value of IN. So paano hanapin tong value na IN? So, from that, redraw the circuit again. This is plus, minus 30 volts. This is 8 ohms. And then this is 3 ohms. Okay. And then, itong CRN. Okay. Maya-maya. This is, it is 8 ohms. This is 3 ohms. This is 30 volts. Okay? I-short natin tong junction na to. Itong terminals ni 6 ohms resistor. So, if i-short natin yan, so there's no current, there's a high current flowing through the 3 ohms. Thus, the current from this junction is now magiging 0. Okay, so high current na siya because na-shorted mo yung terminal. So, therefore, yung current na value natin, that will be the IN. Okay, so this one, that is IN. That gives us, using the Ohms law, we have 30 volts over 8 ohms. Okay, and then it is equals to, that is 15 over 4 amperes. So therefore, the value of IN, this one, is equals to, we have 15 over 4, okay, amperes. So from that, we can have the values known as the current divider. Okay, so to do for the current divider's theorem, if you have I3, that is the total current, IN, that is 15. Okay, that is 15 over 4 multiplied by the resistance of the other, that is 24 over 11 over the total resistance of, we have 54 over 11 plus, okay, 6. Okay, and that gives us 1 ampere. So the same ng answer natin last nung sa mesh at saka nodal. Okay, so ganito mag-solve using the Norton's theorem. So first, draw the Norton's equivalent circuit, this one, and then after that, look for the value of Rn, this one, okay, and then look for the value of IN, Norton's current. Then after assigning the value, you can use the current divider theorem. Next is the thevenin's theorem. It states that in a linear two-terminal circuit can be replaced by an equivalent circuit consisting of the voltage source VTH, this one, in the series with the resistor RTH, and then where VTH is the open circuit voltage at the terminals and the RTH is the input of equivalent resistance at the terminals when the independent sources are turned off. Okay, so the same ng concept kanina. If merong Norton's theorem, meron din Norton's circuit. So this one naman, if meron thevenin's theorem, meron naman thevenin's circuit. This one is the thevenin circuit. Okay, here is the solution. Okay. The same concept yung kanina na ginawa to look for the value of Rn, the same with the RTH. Okay, so let's just redraw again. is the power supply. This is 8 ohms. Okay, so this one, ito na yung tinanggal na load na 6 ohms resistor. And we call this as RTH. Okay, this is 8. This is 3 ohms. Okay, and then this one, i-shorted natin itong power supply. Ito. So, from that these two resistors, again, are connected in parallel. So, thus, our RTH is equals to 8 times 3 over, we have 8 plus 3. And that gives us 24 over 11 ohms. Okay, so the same concept, did you observe that this Rn is the same as RTH? So yung Norton's resistance is the same with the thevenin's resistance. Okay, so ang RTH is, we have 24 over 11 ohms. Yung ating RL, that is this one, the 6 ohms resistor. Okay, so from this, hanapin natin yung value ni VTH. So how to do that? Let's construct a circuit again. We have this 30 volts. Okay, and then we have, and then this is 3 ohms, and then this 6 ohms is now open circuit voltage. Okay, make a label. We have 30 volts, and then this is 8 ohms. This is 3 ohms, and then this is now the value for VTH. So nagiging open circuit siya. So whatever the value of this voltage for 3 ohms, that will be our value for VTH because nakaparallel ang kanyang connection. So to look for the VTH, we have 30, that is the voltage divider theorem. 30, okay, times 3 over, that is sum of the two resistors, that is 8 plus 3. Okay, and then that gives us the value of, that is 90 over 11 volts. Okay, so from that, okay, can we draw at the bottom the thevenin circuit? Okay, and then this is our load. Okay, this is our VTH, and that is, and the value is this one, 90 over 11. And then the value for the RTH, this one, that is 24 over 11 ohms, and then this is the RL, or that is 6 ohms. Okay, then the current flowing through, that is I3. Okay, using the Ohm's law, or we have I total. So our I total is the same with the value of I3, that is the VTH, that is 90 over 11 all over the sum of these two resistors, that is 24 over 11 plus 6 ohms, and then that gives us 1 ampere. Okay, so the same answer again, that the value for the 6 ohms is 1 ampere. Last is the source transformation, in which it is a process by replacing a voltage source Vs in series with the resistor by a current source Is, and parallel with the resistor R, or vice versa. Okay, so from this explanation, we have this simple source. We have one voltage source and then resistance. If we need to transform this, kung gawin nating source transform, itong Is, itong Bs is transform to current source, that is Is, wherein this Is is just Bs over the R. Okay, you can write the equation that Is is just Bs over R, and then itong series na resistor is i-connect mo naka-parallel. Okay, so let's solve this circuit using source transformation. Here is the solution. First, we need to transform this 30 volts, that gives us, okay, so that is 30 over 8 amperes. Okay, and then this 8 ohms must be connected in parallel. Okay, and then connected with the 3 ohms, and then connected parallel with the 6 ohms, and then level 8 ohms. This is 3 ohms, and then this is 6 ohms. Then we have this current I3. Okay, so after that, if ma-analyze mo to, that these two resistors are connected in parallel. So the value for this, that is R, if we get the total resistance, that is 8 times 3 all over, we have 8 plus 3, that gives us 24 over 11 ohms. Okay, after that, redraw the circuit. Okay, be careful. And then this one, okay, then label, this is 30 over 8, the same, and this is 24 over 11 ohms, and then this is 6 ohms, and then this is the value for I3. So to do that, to solve for the value of I3, just use the current divider theorem, in which your I3, get the total, that's 30 over 8, multiply by the resistance of the other, that's 24 over 11, okay, over, that's 24 over 11, plus 6 ohms, and then that gives us 1 ampere. Okay, so did you observe that we have different solutions but the same ng answer. So, na-prove natin na tama yung ating ginagamit na mga theorems. Okay, and then that theorems are based on the engineering circuit analysis. Okay, so I hope na natutunan nyo to solve sa isang circuit gamit ang iba't ibang theorems. Okay, after our solutions sa iba't ibang theorems, we conclude that the value for the I3 is equals to 1 ampere. Okay, so again, to recall, from this circuit, using Ohm's law, the current is 1 ampere. For the KCL and KVL, we have 1 ampere. Mesh current analysis, we have 1 ampere. Nodal voltage analysis, we have 1 ampere. Norton's theorem, we have 1 ampere. Thevenin's theorem, 1 ampere. Source transformation, we have 1 ampere. Okay, so therefore we can solve one circuit ng iba't ibang theorems. Okay, so hope natutunan nyo tong video na to, exclusive to DC circuits only. Okay, so pwede mo itong i-apply if ikaw ay nag-aaral pa lamang ng electrical engineering or basic electrical engineering. Okay, so thank you, and then please subscribe for more updated videos.